Questions 1 through 5 deal with inscribed angles and intercepted arcs. So here, they're given that MN is the diameter of circle Q. So that means MN cuts everything in half, right? So that means that this angle is going to be, this central angle is 180 degrees. It also means that this arc is 180 degrees, right? So from here to here is going to be 180 degrees. They're also giving us that, and the same thing on this side, right? This is going to be 180 degrees. And then they're giving us on this that PQM, so they're giving us this central angle right here is 140 degrees. So if the central angle is 140, then also the intercepted arc is 140 degrees, right? So this minor arc that is described by the central angle, those two have the same. So now they want to know what angle PNM is. Now notice PNM intercepts the same arc as PQM, but it's an inscribed angle instead of a central angle. And what we learned on Friday was that inscribed angles have half the measure. So central angles are equal measure, inscribed angles are half the measure of that arc that it intercepts. So this is a 70-degree angle. So we know that this is 70 degrees, and we know that because it's 140 divided by 2. Okay. Now they want us to know what the arc of PN is. And remember, we said that this diameter cuts the circle in half, so MN is 180 degrees. That means that the arc PN has to be 180 minus 140. So this would be 40 degrees right here. So PN is 40 degrees, that's 180 minus 140, right? And the last thing that they want to know is angle PMN. And again, PMN intercepts this arc PN. So it's an inscribed angle with the vertex on the circle with endpoints at this arc, right? So that means that it's half of the measure. So take half, that's 20. So 20 degrees, and we did that by taking 40 divided by 20. So you write these just to show your thinking process on the whole thing. For this problem, there are different givens. They're given that FG is tangent to circle A. Well, just remember that tangent lines automatically create 90-degree angles. So this is a 90-degree angle, and GCA is also a 90-degree angle. And now they're also giving us that DCB right here is 20 degrees. Now, these are all inscribed angles, right? DCB has endpoints here with a point on the circle, BCE points on the circle. So we can talk about, and again, we kind of see, so we can talk about, we know that this is a diameter. It's going to cut things into 180 each, right? So they want us to find angle GCE and angle BCE. And the big thing to do to figure that out, we want to find out kind of more about what's on these right here. So we know that this arc, if the inscribed angle is 20, then this arc has to be 40 degrees, right? We know that from here all the way to here, all the way around is 90 degrees, right? So all the way around is 90 degrees. Oh, and I forgot one more thing that they gave us. They gave us this arc is 80 degrees. So if this arc from here to here is 80 degrees, then that means that the intercepted arc, that means that the inscribed angle is 40 degrees. It's half. So right there we know that GCE, we have figured out GCE, right? So GCE is 40 degrees. And that's because that's 80 divided by 2. And now they want to know BCE, but these two have to add up to 90. Remember, this is a right angle, 40 and 20 plus whatever's in here have to add up to 90. So 40 plus 20 is 60, and then 90 minus 60 is 30. So BCE has to equal 30 degrees. So I actually didn't need to figure this out. That was an important part for what they had asked us. Although if they had asked us something else about these arcs, that might have helped. But so you use the idea of inscribed angles being half the intercepted arc to get this, and then you used the angle sum that they have to add up to the same thing. So 90 degrees right there. You use that. This tangents make right angles.